So we're talking about how to avoid the absorption issue. One way is to increase the protein concentration in your formulation, so those extra amount of protein can bind on the primary container, or filter that may be used, or whatever the other containers, tubings. Okay, so that could be a way of doing that, dealing with the absorption issue. Another way of dealing with absorption issue is by adding extra surfactants in your formulation. So surfactants will prevent your API's direct binding on the container. So surfactants are like these guys. Sorbate 2080 SDS itself is a surfactant because it's got amphivalent structure, hydrophilic, hydrophobic part. Okay, so they will bind with your drug if your drug is right there in the middle. Okay, so they can stabilize and then prevent absorption, aggregation as well. One way of doing that. Another way is by adding things like cyclodextrin. Okay, so dextrin, it's kind of polysugar. Okay, cyclodextrin is polysugar, but cyclo means it's got a ring structure. By forming multiple combined structure, they form this circular structure. That's what cyclodextrin is. So oligosaccharide, sugar polymer of alpha D glucopyranose contain relatively hydrophobic central part. So inside is hydrophobic, and then outside is hydrophilic. So again, your drug molecule can be maintained inside hydrophobic part, so they can protect your drug that way. Albumin can be added in your formulation as extra protein material. Okay, so especially recombinant human serum albumin is widely used as a stabilizer because it doesn't do any harm when it's injected, because it's a human protein, pretty much a non-harmful protein. So it can be added as extra protein, so it can coat up and bind with your protein as a stabilizer. Other physical stabilizing agents like PEG, PEG, and then PBP are known as their function as a stabilizer at a very low concentration, less than 1%. If we have to use them, just add a little bit. Okay, and then let's see. Optimizing antimicrobial activity. Again, multi-dosage formulation should have antimicrobial substance added. Okay. So far about 25% of parenteral drugs packaged and sold as multi-dosage formulation form. Okay? You can give them multiple injection using one vial, one container. They require effective antimicrobial preservative, AP. Okay? So most antimicrobial preservatives used in multi-dose formulation are phenol, metacresol, or benzyl alcohol, those kinds. Okay? And then you have to prove their effectiveness by doing the PET test. PET stands for preservative efficacy test. You have to do experimental data gathering about the effectiveness of these antimicrobials. Okay? So how does that work? That PET test, the way it works is you have to formulate your drug formulation with PET that you are testing, and then to that formulation you're going to add bacterial cells and then fungi cells together. So at least 5 different species of well-known bacterial cell, and then 2 fungi species, so total 5 microbials are mixed up together, and their concentration will be 10 to the 6th CFU. That means cells per mil. In 1 ml formulated liquid, there are about 1 million cells of those existing, right? And then you incubate that suspension about 7 days, 14 days, 21 days, and 28 days. Okay, at each interval, I guess, and you plate them. Okay, and see how many cells are still surviving. Okay, if you had this the AP in your formulation, would they be still surviving, or would they drop down because of the presence of these? So that should be demonstrated. Okay, how many cells are still found after 7 days, 14 days, 21 days, 28 days? So in log value of inoculum, remember those things we talked about, D value, Z value? So that's what we were talking about. Okay, so log value of survivors at the time point. Okay, 7 days time point, 14 days, 21 days, 28 day time point. You'll have to report that. See, you can even do 6 hours. How many cells are there? 24 hours, 2 days, 7 days, 14 days, 21 days, 28 days. Okay, you have to demonstrate no increase of the CFUs throughout those testing time point. That should be the the result you get. Okay, that's a PET test. Understand where PET test is used and what does it prove? It's the efficacy of antimicrobial agent in your formulation. And that's what it's tested for. So antimicrobial formulation ingredients may have negative impact on the physical stability of the protein itself. They may cause like precipitation, aggregation, and phenolic compound could cause aggregation, like human growth hormone, things like that. And benzyl alcohol above certain concentration can cause aggregation. So you have to be careful. That's what it says when you use those. Don't use too much. It can damage your drug molecule. And then osmolarity agent. Again, osmolarity, tunicity, similar way. The salt concentration is what you're talking about. Okay, isotonic is ideal, as you said. Okay, but they may have to be adjusted. So non-electrolytes are preferred instead of electrolytes. So electrolytes are ionic, so don't use too much of ionic salts. Epidural injections. You know what epidural injection is? Injection to your spinal cord, okay, into the cerebrospinal fluid requires very precise specification for isotonicity. What does that mean? Since your injection is given to the spinal fluid within your spinal cord, okay, you don't want to mess up the concentration of ions within your spinal cord. That's what it means. Okay, so you have to formulate very precisely. This almost isotonic condition should be required. If you mess up the ion concentration of your spinal cord, you will have a lot of massive headache and a lot of problem. Okay, so you don't want that. I think I don't know. Some of you may have baby, and you might have the epidural shot injection during that time. Then you may have like some headache because of that. It's because of that. Some change of electrolyte condition through the epidural injection. Hopefully that didn't happen to you. Okay, so that's the end of the formulation. So these are some examples. So for each of the commercial parenteral drug formulation below, so I'm giving you 1, 2, 3 different kinds here. Okay, so identify the purpose of each excipient within a formulation. For example, if you're talking about this napsin manufactured by Eli Lilly, so it's got 1, 2, 3, 4 different kinds of components listed in its formulation, right? Tobramycin, 80 milligram, probably that's the API, active pharmaceutical ingredient. Then how about these 3 other guys? What are these used for? Okay, sodium bisulfite, that's probably a buffer, right? How about disodium EDTA? We know that that's a chelating agent. Okay, so that's sucking out the metal ions. Phenol, what is that? It's probably antimicrobial preservative, right? Okay, how about Valium injection? Okay, it's got 1, 2, 3, 4, 5 different kinds of formulation components. Okay, so which one is the API? Probably it's diazepam, 5 milligram, I think. And propylene glycol, what is that for? It's a surfactant, a stabilizer. Ethanol, what is that for? Okay. And benzyl alcohol, probably it's an antimicrobial preservative. And what is that? Benzoic acid and sodium benzoate. You find out what function they serve. Okay. And then next formulation, Neutropin AQ by Genentech company. Somatropin API, probably, right? Sodium chloride, salt, okay, tunicity adjuster. Phenol again, polysulfate, sodium citrate. Okay, identify what their formulation functions are. Okay. So assignment here, read the formulation development of printed product handout, or you can download this textbook material. Okay, it's in your syllabus where you can download it from. The link to that website is there. And understand the following terms and concepts: injectable solutions, injectable suspensions, how are they different? Injectable emulsions, suspension versus immersion. Suspension is totally not soluble API. Immersion, strongly hydrophobic API, so they has to be what? Dissolved in probably hydrophobic like oils, right? So those are emulsions like protofol and things like that, like milk-like solution. And how surfactants prevent phase separation in immersion, okay, because they have that amphivalent structure. Okay, they can prevent that, immersion, separation of immersion. Pre-formulation assessment, pre-formulation development, what kind of things are being done during those times, and degradation profile, what do they do, what do they study, formulation development, how is it done, buffers and pKa values, okay, what are the importance of those, antioxidants, what do they do, stabilizers, what do they do, bulking agents, what are those and what do they do, process compatibility and scale up process, and the filter studies. Okay, and finally, assignment questions. What is the most important solvent used in formulation? Solvent, among the most important ones, the water is the probably prevalent, one of the prevalent solvent that's used, right? Because a lot of molecules are water soluble. You use UFI, water for injection, for that. What is the main function of complexing agent? Again, complexing agents, understand what they are. What do they do, complexing agents? Where are they? There you go, complexing agents. And surface active agents, so they increase, maintain drug solubility. Okay, so cyclodextrin, 2020, 2080, those are the examples, right? Okay, so then what is the main function of a buffer? You understand what buffer is? It's the molecule that resists a pH change. What are cryo or lyoprotectants? Cryoprotectants, molecule that prevents freezing damage of your API. Lyoprotectants, that's a molecule that prevents the drying damage of your API, used during the freeze drying, lyophilization. What does the preservative efficacy test measure? PET test. Okay, that's measuring the efficacy of your AP, antibiotic, formulation component by, mixing up 3 species of microbial, 2 species of fungi together and adding them, mixing them with your formulation with the AP present, and see at the given time, 6 hours, 12 hours, after 1 day, 7 days, 14 days, 21, 28 days, and see the number of cells still existing, or how many cells are there. So log change will be observed, right? That's what PET test would do. Okay, so this is it. Thank you.